So everybody ready to start the second half of the training workshop?
Yeah.
Do we have everybody? I feel like we're still missing quite good.
Actually, I'll be right back.
Do we missing anyone?
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.
I know there is a 10 here, 2 here. So, oh, okay, then we're good then. So, why this? What is going on? The projector is not working. Good, this should be good. Let me see. Did it show up? Okay. So I think in the morning we went through the stage up to a linking T3 project with D2S. That's where we stopped. And I think we were trying to actually load that plot boundary we created in QGIS into the Jupyter notebook, but that's where we figured out there's something wrong. So we unloaded that plot boundary into QGIS, and we're gonna re-download that file because they'll take care of all those kind of other stuff. So I'm gonna stop from there. So let's go to our data to science project here and go to the project that you created this morning. So in my case, this is the one test project that I created. So is everybody here? Okay. Let's go to map layer. That we unloaded this in a plot boundary WSN84. That we are going to download this into our computer first. So I'm going to click this GeoJSON. And it'll ask me, how you want to download it. I think I just use the same file. So to differentiate that this is a new file that I just created, I'm going to say that from D2S. I'm going to just add the additional. You got this already lost?
No, well, I just was on another web page. I had too many instances open.
So going to your project, I go to map layers. Click GeoJSON and say how you want to download these files. I'm going to just set that from D2S so that this that this is actually a file that you download from D2S. Okay. Then I'm going to click Save. Again, this is a file that you downloaded from your D2S to your computer. Your Jupyter Lab is running on the Purdue Data Center. So you have to upload this downloaded file to your Jupyter Lab server again. So coming back to your Jupyter Lab here, and I'm going to drag and drop the new file that I just downloaded from the Data to Science platform. Drag and drop here so that you're going to have that file uploaded to your Jupyter Lab instance. Then you're going to see plot boundary WS84 from D2S.geojson file available over there. So everybody good so far? Okay. Now, make sure that, I think you haven't done anything, so what we're going to do is we're going to scroll down where merge the plot boundary attribute and the T3 data section. And we need to change the file name here to be now plot boundary WS4, but from D2S. We're going to change the file name. And after this, I'm going to click play button. And now you should see that this code is run, and we are loading this GeoJSON file into Pandas, the Pandas data frame. And this shows us in the first 5 records in that GeoJSON file. So what is in a layer name, layer ID, etc. And those are the all irrelevant information, but the most meaningful information is this geometry, is the actual geometry of the individual plot boundary. Oh, am I going too fast? Oh, sorry. So you upload the GeoJSON file, you download it from D2S to your computer, upload it to your Jupyter notebook, and simply changing this GeoJSON path to be that file name that you just uploaded. So it is this file name, that this is the one that you just uploaded. It should have exactly the same file name here. Work? Okay. There's like a key, we give a few minutes. So the one that we created from QGIS has some, how should I say this? Not wrong, but they store this in the data type as a multi-polygon, even though this is, in GIS, there's a simple polygon, which is polygon without any donut inside. But the multi-polygon, you can have a more complicated geometry inside the polygon. But in QGIS, they just, essentially, the save it as a multi-polygon, even though it's a simple polygon. And these pandas, we are, using GeoPandas packages in a read file, the provided GeoJSON. That's where this, GeoPandas package doesn't know how to interpret. So, I think either we fix this data type manually, or what we did here is that we upload it to data science platform, because we already wrote a code in data science. Whenever this the complicated file structure coming in, we are cleaning this up, and we just store only those in a simplified version. So we just upload it to the data science to do the cleanup automatically, and then we download it. That's basically what we did. And by doing so, this data science platform is adding additional columns. So what is in a layer ID? Is this active, project ID, flat ID? Those the additional column has been added, because that's the way how we know which which polygon belongs to which project and which flight, and etc. But essentially, we're just doing a cleanup using the built-in code in data science, and yeah, that's what we did. Okay, so like I said earlier, once you do this, and this geometry saves the information about the plot boundary. Row and column is the information from that the plot boundary tool that we just generated, and we're just looking on the first 5 records. So what we are doing next here is that to give you an idea how this different origin is affecting this geometry. This plot map plot boundary. This is the one that we are printing out plot boundary layout from the QGIS plugin. So all you need is simply choose this one, click this play button, and we just choose this one again, click play button again, then this will print out this plot boundary layout. Like I mentioned earlier, our origin is top left. You see that R1, C1, this is row 1, column 1. Right next to it is row 1, column 2, row 1, column 3, and etc. Next one is row 2, column 1, etc. This is how we actually define in QGIS in a plugin. So this is how it looks like. Next, I'm gonna just scroll down. This is in a prepare T3 layout. So what we did earlier is, let me see, since we already have those, downloaded this, what is that, T3 field layout information at the, way at the top. If you remember, getting T3 information, we need to type in the trial ID. Then we just save this to CSV file, remember that? And during that process, we also generated some data frame during this in the process. So essentially, this T3 plot is a data frame that we just loaded in the earlier stage. So that's the reason why we don't have to specify where is those T3 layout is coming from. We essentially loaded this one at the earlier stage of the code. So coming back here, we just got this T3 plot. You see this loaded over here, and I'm just printing this out. No, I'm just doing some additional process. So let me just run this cell. Then you should be able to see that this is in a field layout.cs file that we got just earlier. We have a name, row, column, plot ID, and a plot number, etc. And this next one is printing out T3 layout on a map. So, but as you can see, this is a row direction, column direction, and you can see that the origin of this T3 layout is at the bottom left, not the top right. Plus, if you look at this, they have 10 column and 12 rows, right, in T3. And if you look at the plot boundary they just drew, you have 1, 2, 10 rows and 12 columns. This clearly indicates that, hey, this is not one-to-one match. You have to rotate this in a 90 degree, essentially. So we have in the top left corner, you need to rotate 90 degrees so the top left corner becomes in the bottom left corner. And you need to swap row and column, because once you rotate it, the row and column you need to go rotated as well. So essentially, based on this printout, you're gonna say that, hey, I need to rotate 90 degree counterclockwise. I need to swap row and column of my plot boundary layout. Then this row and column index will match with a T3 row and column index. And simply said that, this is code that I'm doing over here. I'm selecting only necessary columns from T3, so I'm gonna run this cell, come back, and what did I run here? This is the one that I ran just, right? Have I ran this one yet? No. Yeah, so this is what I read, okay, 48. Then this is if you look at this carefully here, row and column, you see the row and column. I'm just kind of swapping this, row and column over there. So that's, I think, what I'm doing. So basically, if you just look the code carefully, I just rotate 90 degree, swap row and column, and make sure that this row and column matches. Then after this, I just print out this final spatial layout. Now you have, this is in a row and column layout from T3, and this row and column is in a match with whatever we got. Once you have this one, I'm gonna just do the join operation based on row and column from both the plot boundary and T3 layout. I'm just pulling plot ID information from T3 layout, add that as an additional attribute in my plot boundary shapefile. I mean the polygon. So I just simply run this. It says that total rows is 120, match rows is 120, so everything matches. So you went just fine. And if I just run this cell here, now I have column and row, and the most important part here is the name, plot ID, and plot number has been added to each of these geometry that we got. Okay? So this part, you don't need to do anything. All you need to do is simply download this plot boundary from D2S, change the file name to be this one, simply running this in the cell in the row. And at the end of this file here, then you're going to be saving this in a file, merged in a geodata frame into a file. So in this case, I need to change this into something that is meaningful to you. So plot boundary with, I'm going to say the plot ID. Okay? And I'm going to simply delete this here. I don't need to say what this in a file is going to save to. And if I just run this cell again, now you save this in a merged in the GeoJSON file. That if you open this up, you see that plot boundary with this GeoJSON, plot boundary with the plot ID, that GeoJSON file, has been newly created. So I just want to make sure that everybody has this in a new file created, available in your Jupyter Notebook.
I got an error. I did something wrong.
So probably you didn't run the previous cell. So make sure you are running everything from the top.
Okay. Yeah.
So let me just run this. Run OK. Run OK.
Everything was fine until that one step. I maybe changed the name wrong. Yeah.
Probably you
My
missed one of the cell.
Thanks, Jinha.
No problem. So does everybody have this file generated on your computer? I know the AJ is helping one in the back. Good? You're good? All good? Okay, so now this is plot boundary file. Now we had the additional plot ID attribute attached to it. Like I mentioned earlier, this is plot ID is a unique ID in T3. This is going to be key information for you to be able to push whatever the information you extracted in the future. So what I'm going to do here is that I'm going to download this, the new plot boundary file to your computer so that you can upload this back to a data to science platform. Because right now, what we're going to do is that this is a boundary that we're going to use. We're going to do the journal statistics based on this boundary. Okay, that's the idea. So let me right-click this. I'm going to click download to your computer. So I'm going to click download. Then once you do this, you just download to your computer, save it. This is only 50 kilobytes, so it should be going pretty smooth. So coming back to your project, now you have a map layer. Then you're going to upload the newly downloaded plot boundary with a plot ID, add to it, to this one over here. So I'm going to browse plot boundary with a plot ID. Let me click open and click upload. Then you should see the success. And close this out and refresh this page in a couple of times until you see this plot boundary with the plot ID layer has been populated. So I'm going to give it in a few minutes to make sure everybody has this. And once you have this, now we don't need to have two. This one is without the plot ID. I'm going to go ahead and delete it because having two can be always confusing. So make sure you delete the one that you uploaded before, not the one you just uploaded. So I'm going to delete this, remove map layer, then you will end up having only one available in your map layer. Are you good? Anybody having an issue? Raise your hand. We'll come help you.
So we delete the WGS.
Yeah, WGS 84 you delete. Can I go to the next stage? Okay, so I'm just kind of laying the foundation. So now we have a plot boundary. This each of the plot boundary has a plot ID associated with it. Now it's time to do some phenotypic trait calculation. There are many different traits that we can do, but the one that I'm gonna play today is excessive greenness index, because we have the RGB. With one of the popular the vegetation we can calculate the EXG. So I'm going to show you how to do this. But if you have multispectral, you can do NDVI, NDRE. There are so many different vegetation. This is either you can just write your Python code to do it, and there are some built-in function in data science. I'm going to show you how to do this. And you can even load this into QGIS, and from there you can do the band math tool to do the actual calculation over there. But let's do the EXG calculation first. So let's go to flight, open up the manage data, and for this vegetation in this calculation, we need to do it from also. And if you look at here, there is a toolbox button. You're going to click this, and make sure that this band description is set correctly. Depending on some sensors, they don't have enough metadata, and especially with the multispectral. You need to know the band order. Some multispectral start with a green, red, red edge and infrared. Some multispectral start with an RGB with a red edge and infrared. Sometimes they do BGR instead of RGB. So this is sensor specific. But most of the RGB camera, this information is set automatically in RGB. And based on this, if you like to calculate the EXG, simply click this. And that they will assign this band required to calculate EXG automatically, because if it is set to red, green, blue, they will pick up automatically. So this one looks good. Make sure that the red is assigned to red, green is assigned to green, blue is assigned to blue. Simply click start, then just click out, then you see that EXG calculation is happening on the the server side. So this will take the few minutes, depending on how big yours is. I don't think it's going to take that long for this one. But that's how you can calculate vegetation indices. And if you like to calculate other, if you click toolbox here, you can just do calculate vary here. They will just pick up the same value. Click start. They will calculate the very visible atmospheric resistance index can be calculated as well. To give you an idea of multispectral, we don't have that one. But if I go to another project where we have a multispectral, go to here, we have ortho here. If you go to toolbox, you see the blue, green, panchromatic band is 3, fourth band is red, red edge, and NIR. This is a thermal band in upper channel. This is set correctly. And now you see NDVI available over here. If this is a multispectral, if you pick this one, they'll pick the red and NIR automatically based on this description. Okay. Then if you click start, I'm not going to do it because we already have NDVI available over here. So if you have the other sensors, you can do some basic vegetation index calculation in this D2S directly. Okay, let's go back to the project, hoping that the other one that I initiated is available. See, yep, you see the EXG become available here. I'm going to click view, and you may think that, hey, where is all those kind of black dots over there? I think this is kind of limitation of cloud optimize, because they are showing the data set at the zoom level that you're looking at. That's the reason why we can load these data sets so quickly. And at this level, there are certain pixels that value is low. It shows a kind of black empty box. But as you just zoom in, see that the empty box disappears. So it is not the problem of data. Simply that the zoom level that you're working on is kind of causing those kind of issues. And the same thing over here. You can choose a different color map. So if I just choose that, their color representation will be updated. I just set mine to be 0 to 1.2. If you just do the min max, it looks quite different as well. But you can just set whatever value that you need to get the visualization contrast that you need. So everybody was able to generate the EXG so far? Good? Okay. Next step is we're going to do the zonal statistics. So let's go back to workspace. Go to the project. WheatCAP. Over here. Then I'm gonna go to manage data. And we like to do journal statistics. What I mean by journal statistics, and now we have the boundary. We like to know what is a mean value of EXG within the boundary, what is a standard deviation in the etc. That's what I mean by this. And we know, in order for us to do journal statistics of EXG, we have to do some operation in EXG. This is why we have to click this in the toolbox of the EXG over there. Now you can do journal statistics over here. Okay. Oh, you know what? I'm in the wrong project. Sorry. 2025 WheatCAP test. This is the one that I need to use. Toolbox, journal statistics. Now you will see that in the map layer that you uploaded into your the map layer, you're gonna choose this specific layer. So this is what I mean. I'm gonna use this EXG as a base map layer. I'm going to overlay that plot boundary that I generated. I'm going to go, one boundary by one, clipping out all those EXG value within the plot, and you just calculate what is a mean and standard deviation and the additional, the statistics. I'm gonna just keep repeating for all the boundary that I have in this, map layer that I chose. Okay. So for this, you just need to click Start. Then they will be actually doing journal statistics in a calculation. And if I just click this, journal statistics, when the calculation is done, now you can download the result as a CSV or in a GeoJSON. CSV doesn't have a geometry information embedded in it. And GeoJSON, you can also load this into your QGIS as in a vector layer. But in our case, we are going to download a CSV file. Okay, so I'm going to click Download CSV. Please don't change the file name. We just came up with some kind of structure where we can actually parse out this file name so that we know when this plot is done and what kind of phenotypic the trait that this file contains. So please don't change the file name to anything else and just save this whole thing as a file to your computer. So I'm going to just click Save. And you see that this is a WheatCAP training workshop test in a year, month, date, sensor, the layer name, and journal statistic.csv. Okay. Once you have this, now we're going to go back to our Jupyter notebook. Then I'm going to upload this file to our Jupyter Lab server, drag and drop. Okay, now then you're gonna see this is in a 2025 WheatCAP training workshop. This is in a long file name. Let me just do this. So this is in a file name that you got. What I'm gonna do is I'm going to copy path. Okay, I'm gonna copy path. Then coming back here, now, oh. We're going to use the copy information later, but I think the next, the example here is how we can actually load the example, some of the layers inside the Jupyter notebook. So let's quickly run this in a code here as well. So we're going to be connecting the data to Science and Platform. So I'm going to run this cell. Then also I'm going to run this cell to connect. So you need to type in the server URL and your username. Then it is going to ask me a password. So I'm going to choose the one, whatever the password that you got, type enter. Then you should see no error messages. That means that now you're connected.
Give us a sec to catch up.
Yep. Are you good? If you don't say anything, I'm going to assume that you're good and move forward. If you need more time, let me know. It's okay to just ask for more time. So everybody connected to D2S? Nope. Give me a sec. So having issue? Okay. Yeah.
Successful.
If you don't see any error messages.
Okay,
Yeah.
perfect.
Yeah. I know sometimes just clicking play button can be very boring, but if you know what you guys are doing, actually writing code is a lot of fun. So I highly recommend you guys study this code, and once you understand what is happening behind it, you can just change it to whatever things that you like to do based on this code. Okay.
Do we need to change the email?
No, to your email.
To our
Yeah, of course. Yeah, because you don't know my password, so I don't know your password neither. So we are getting very close to the end. So
It should take just a few seconds to connect to the.
yeah, it shouldn't take that long. Is there any issue?
It doesn't stop logging in. It's stopped in here.
No, it's not running yet. So I think it's not.
Enter.
Yeah, done. It is finished. Now you can go to
Finished?
Yeah. So every time you just
okay.
change the number without any message, it means they ran okay. Okay. So once you have this, and there is a couple next line, basically what it's doing is that some of those procedures that we're working on, you need to authenticate who you are. And some of the, we're using the Python module called data to science Pi, D2SPI I like call. And D2SPI know how to authenticate who you are because you already provide the ID and password. But some of the other open source library, if your data set is protected, they don't know how to access this data set without going through authentication. So that's the reason why we are grabbing this in API key I mentioned earlier. This is going to be a secret key that you can use to say that, hey, this is me, this is you. You can use this in the API key to authenticate who you are. So we are grabbing this in the API key information programmatically using this in workspace.api key after you log in. We are storing this information into an environment variable called the D2S and an API key over there. So all you need is simply run this cell, then there should be no error messages. Okay? And the next part, I think I can just go a little bit more detail. Once you connect to the workspace, you said that give me all the project. But once I get all these projects, I want to filter project by title. Whatever the project has 2025 WheatCAP as a part of title, I'm going to only show look at this result. So if I run this cell, now in my case I have 3 different project that has 2025 WheatCAP, but this is the last one that I see over here. This is the one that I created for my test. So first one is the one that I created for this in a workshop. You guys created your own, right? So this first number is the index in a Python using a zero-based index. So first project is going to be index of 0. Second project is index of 1. Third project is going to be index of 2. In my case, I need to pick up the third project because this is the one that I have all the data that I need. So in this case, I'm going to pick up the third project, which is index of 2. In your case, it can be index of 0, index of 1, depending on how you named it. So I'm going to just run this cell, and you should see no error messages so far. So far, so good. Let me go help him just to make sure that he can follow up. Any problem?
Yeah, I think it's not connected. It's okay. He refreshed these pages.
Yeah,
and
so simply restart the kernel.
Yeah, restart the kernel. Yeah.
And yeah, start from the top.
And then you have to run everything from.
Yeah.
Yeah. So you can see.
Start from the top. Try to catch up to the part that we're working on. Don't miss any cell, because if you miss any cell. Okay. So I chose a specific project that I'm interested in. Next, I'm gonna set what is the start date and end date so that I can filter by date. So in our case, we only have one flight, but you have 20 flight in your the project. Then you may want to say that, hey, I want only flight within this the time range. This is kind of technique where you can set what is the starting date, end date, so that you can get all the flight, but the filter by start date and end date. In this case, I'm just saying that, hey, give me all the flight that is in between April 20th and July 15th. So if I just run this, we only have one, so you're going to see only one flight showing up over here. Okay? And out of this many flight, I'm going to choose the first flight, so flight 0. Are good? Then I'm getting all the data product this specific flight has in. So I'm going to just print this out. Then you're going to see this is kind of messy, but you see index of 0. This first data products in a DEM. Now index of 1, where is 1? 1 here. This is a point cloud. Index of 2. Where is it? Yeah, here. This is an ortho. Index of 3. This is an EXG. Okay? So I think I'm just pretty much doing the same thing here. Let me just run this again. We should get the same. Index of 3 is in an EXG. So I'm going to be actually visualizing this in the EXG layer inside this in a Jupyter notebook. So I need to choose index 3, which is in a fourth data product. And I'm going to run this cell. And I think this one is, Chiseng and I was debugging a little bit, so don't worry about it. But I think the code that you got is this one. Right? And I believe app string, give me a second. I changed the code a little bit, so I'm trying to. You see the field?
Yep.
Okay,
See
yeah.
Google Earth
Yeah,
or
yeah.
whatever.
But basically, I need to copy this. I know that Chisang is working on.
Fine on my end.
Oh, really?
Yeah, it might be your version is little bit.
Sure.
It might be. Can you check the
I
version install on your?
try to update to the latest version by doing pip install. But, maybe you and I can check later.
Yeah, it works on my
Yeah,
end. Like
yeah.
I don't change anything.
Yeah. Yeah, but you see, now you have this layer. I'm using the jack color map. I mentioned earlier, as you start to zoom in, you're going to see those, the empty dot will disappear. Now you can actually visualize this in a data set inside in a Jupyter notebook.
Which data product like
EXG,
index?
excessive greenness index, EXG. So let me go.
Number 3, yeah, number 3.
Yeah, but I think depending on your setup, your number 3, where is it? 2 data product. Your number 3 is a point cloud. Okay. So don't copy it. So you need to find the data product that is EXG. So scroll over.
Number
0. Yeah.
Number
So
0.
then in your case, it will be 0. Yeah. No, can you go up? I think you haven't run this, the other cell. You have to run this cell first. Then the one next. Now you see? Yeah. Yeah.
Is there an easy way to tell which
understand.
index we're on here? Because when I just started messing with it and changing the data products.
So you need to look at this in a printout here. 0 index is EXG.
Oh, okay.
1 is vary.
Yeah.
2 is DEM. So you're looking at DEM
Yeah.
right now. So
Okay,
if you
so-
choose to change it to something else.
Yeah. Which one are you on?
EXG. Yeah. But this is just one example. You can actually load the ortho. You can load the DSM. I think she's saying you are also working on point cloud visualization inside the Jupyter Notebook as well
No,
in the future.
yeah.
So basically, you don't have to leave this in a Jupyter Notebook environment. You can visualize it, you can interact it, and we have a ton of other more advanced the Jupyter Notebook example where you can do more advanced the phenotypic extraction. But essentially, you have this in the EXG loaded over here. I think I just include this in the code so that to show you guys that this kind of thing is possible. Next is that now we downloaded the journal statistics file. Remember? Then we need to actually upload this journal statistics to T3. And the way how it works is that T3, we know when the data was collected by flight date. But that flight date is already embedded in the file name. You remember 2025 WheatCAP project name. We have a year, month, date information already embedded it. So going back to this file that we just uploaded over here, this 2025, this is first up to this point is the project name. When the year, month, and date, this is the date when the data set is collected. We have also layer name is embedded here. So this file name already contains a lot of information. And as a part of additional file inside this GitHub, you're going to see the drone trait and the sandbox and drone trait WheatCAP CSV file. And if you open up the sandbox one, this is the actual lookup table. Depending on what trait that you are looking at and what is your Julian date. Julian date is starting from January 1st and how many days we had up to that flight date. So we need to do, for example, here, if this is the, let me just increase that one here, canopy cover. If this Julian date 1, trial DB ID is going to be this one here. So this is going to be the one that you need to push. And if you just scroll down up to 365, you see the canopy EXGI, excess greenness index value. They have a different trial DB ID. So depending on what specific phenotyping, the phenotypic variable you're looking at, what is your Julian date of your flight, we need to retrieve this the trial trait DB ID information extracted. So basically what we are doing in the next part of the code here is I'm going to first load that the journal statistics in a CSV file that I downloaded. So now going back here, I'm going to be copying this in a file name. This file name is something that I tested, which is going to be different from what you guys have. So I'm going to copy path of this in a file name, the CSV file that you just downloaded, or copy it. And coming back, and I'm going to change this file name to be exactly that one. But what I'm going to do is that I'm going to delete everything up to the folder. So essentially, you only have a file name without any relative path. And after this, if you just press this play button, then you should see this pandas data frame shows up. If there's something wrong, then you're going to see error messages. Have you guys good so far? Good? Next time, we need to load that lookup table. Since we are working on the sandbox, you need to use this lookup table for sandbox. If this is a WheatCAP project, we already provided WheatCAP.csv file as well. So, but in our case, we're going to be working on the sandbox lookup table. Run this cell, then make sure this is the printing out the table structure properly. And we have a couple of additional function that is doing the flight date to Julian date conversions. And I think there are some other function that we do to do some kind of table merging and etc. So I'm gonna run this cell. Nothing is gonna happening because we are simply defining what is the function that we are gonna use in the next cell. Next, we need to copy that the CSV file we downloaded. So I'm gonna go back up the CSV file. Where is it? This one here. I'm gonna copy this in a file name that we just loaded again. Control C. I think we could have just recycled whatever the name that we got, but I'm gonna paste that link over here. I'm gonna load this into pandas data frame, lookup table. Again, I think this is repeat of the previous one, but using the function that we defined, we are just preparing this the data frame over here. So when I run this cell, there's some error messages here. It says that essentially name RE is not defined. This is a regular expression module that has not been loaded. So probably I forgot to run this cell here. So I need to run. So I'm importing this in an RE module, but this has not been loaded. If you guys run this, you're not going to get error messages. So I'm going to be just doing. Another thing here is that base name. This is the EXG. So going back to this in a lookup table. This EXG is defined as a canopy EXGI. That's the reason why I'm setting this to be a EXGI instead of just EXG. And you can just to check this in a lookup table to figure out what base name to use for for example NDVI and other vegetation indices. So I'm going to run this cell. Now I'm not getting any error messages. Then I'm just printing out the first 5 line. This is what I got. So basically, what we are getting here is that combining whatever the journal statistic file that we got with the file name, merging those two information into this actually lookup table. They combine this into it, so we just prepare this table. So for first one here, the mean value is this much, standard deviation is this much, value standard deviation is this much. So I believe this is, I don't, this is a unique ID. This is another unique ID for the mean of EXGI. This is another unique ID for the standard deviation of EXGI in a corresponding values. So don't worry about this. They just essentially merging this in a CSV file with a lookup table so that we can just prepare this in a table that can be used to push this information to T3 database. Good so far? Okay. Next, we're going to push this in extract phenotype back to T3. So I'm going to run this cell. And first, you need to check what is an access token, pretty much the same way as we need an API token from D2S to authenticate UR. Same thing in the T3. In order for you to do any programmatic the operation, you need to provide an access token. This code is essentially giving you the access token. So if you just run this, it'll ask you what is username. So in my case, this is mine. And what is your password? Let me go grab my password. And the sandbox here. I'm going to copy my password, paste it, enter. Then this will print out your access token.
Is this the T3 or is
This is a sandbox. Yeah, with sandbox access token. If you're using the WheatCAP, this is going to be different. Okay. So everybody got your access token printed out?
Not yet.
Okay. I'm gonna give you a second. Make sure you copy this. I'm gonna copy this. Because in the next step, it's going to ask you, what is your access token? What is the ID and password again? Good? All the way? I know Shannon, you need more time, but you guys okay? In the middle? All good? Oh, Shannon, you forgot your password.
I have so many instances of this.
But I think that it's just a matter of typing in access token ID and password. So if you look at this one here, you may have to change your base URL because this is the sandbox. If it's a WheatCAP, you have to change it accordingly. If you're just looking at the token, but this function that we are hearing is that essentially we are pushing this phenotypic trait back to the T3. This is the function. Essentially, what you're doing is a token get access token there. If it's token, then we just push observation using token and the push data frame. So this is basically what we are doing. So I run this cell. It'll first ask you access tokens. So I'm going to paste that access token information there. What is your username? Okay. What is my password? I'm going to go get here. Not this one. Sandbox copy. Paste it. I'm going to scroll down a little bit. If you just press enter, that now they are processing plot, uploading in batches. This program is the program to upload 500 in batch. We only have 240 because remember we have 120 plot. We have a mean and standard deviation, so 100 times 2. That's the reason why we have 240. It just said that batch 1 upload 200 record, upload successfully, or 240. So you should see these messages. All good? Then what we need to do is going back to your T3. Coming back here, I'm going to refresh your trial page. Then scroll down. Then you have this phenotypic raw data. Click this. Now you should see Canopy EXG. Canopy EXGI, standard deviation, becomes available. So you basically extract, calculated a mean and standard deviation of EXG from T3, the D2S, using this code, push this back to T3. Now this becomes available to everybody who is in this WheatCAP program. I just showed an example of EXG only. You can do the same to get NDVI, whatever the other vegetation indices. A little bit tricky part is in structure-related information, which is canopy height. We don't have a mean and standard deviation. That one usually take only maximum. Canopy volume. Those are the one we don't have any established pipeline in D2S ecosystem yet, but that might come into play. But as long as you have these zonal statistics in a format that you already have for the EXGI, you can use the later part of the code to push this information to T3 as well. So you guys feel confident that now you can do everything from A to Z, right? We started from raw data, generate this and also point cloud and DEM, and link this with a T3 database. Then we delineate the plot boundary. Of course, we had to do a little bit of cleanup. Then merge this plot boundary with a T3 field layout so that this plot have the plot ID associated with it. Using that one to do the zonal statistics, download the CSV file, and push the CSV file back to the T3 database. That is essentially the whole process that we've been doing for you guys for the last 3 years. And then I know that this is going to be something it'll take a lot longer for you guys to get familiar with. We'll be more than happy to keep providing those services, but eventually, I'm hoping that you guys can kind of learn this technique so that you can just do it yourself.
I have a question.
Sure.
So let's say we estimate EXG again and try to upload for the same plots again. So will it update automatically?
Yeah.
Okay.
So it will overwrite if we are uploading the same thing. And essentially, I think a code that we got is that if they're going to compare the value, if it is the same, it is a skip. If it's different value, they will update the whatever different value only. Yeah.
We try to get the token,
Okay.
but there is no token here.
I had one before, but then when we put it at the bottom, it wouldn't work.
I think this is something where we have to ask John-Luc.
What's going on?
He doesn't have access token. I think it generated.
We ran it
Yeah.
before.
And I think we are up to an hour, so I'm going to stop here. And we're going to take a 15-minute break. We'll come back at 2:15. And Jean-Luc will come to stage again, and there are a couple of steps that he'd like to show. And I like to end this presentation. Remember that plot boundary delineation was, sometimes it can be very painful. And sometimes your plot layout is not regularly spaced out. Sometimes, one row is a meter or apart. The other row might be half meter apart. Sometimes it might be zigzag, all those kind of crazy stuff happening. So what I want to do is that I like to demonstrate that the AI, the plot boundary delineation module that we developed, and I will give you the GitHub URL so that you guys can get a copy of the code. But I will do the demonstration. Keep for your information, all this in AI requires a pretty good GPU. Otherwise, it's going to be very slow. Even with the regular CPU, it will work, but it will take a lot longer than the one that I'm going to demonstrate to you guys later. So let's take a quick break. We will convene again 2:15.